A warm good afternoon class. In the previous video we have seen what is time, speed, distance and the major areas where this questions comes into the picture in most probably in competitive exams or in gate exams where the time, speed, distance problems plays a vital role, and these time, speed, distance have variants like a problem on trains, problem on boats and steams, pipes and cisterns, races and clocks. So this time, speed, distance topic has many ways, have many variants, so that in this particular video we'll narrow down the topic and see towards the problem of train. And here in the last video we have spoken about the problem on train where it is used intensively, right? So here you are going to have a small glimpse about what is the relationship between time, speed and distance, a small recall from the previous video. As I already said, speed is equal to distance by time. That means it tells how slow or fast the object moves. Means that the time the distance covered in a time taken, okay, distance covered divided by the time taken. So you can see here the speed is directly proportional to distance and inversely proportional to time. Here you can, as a simple example, if you take for example, if for 1 hour you are going for 10 kilometers means the speed is 10 kilometer per 10 kilometer per hour, right? For 1 hour if you are going to 10 kilometers, then the speed is 10 kilometer per hour. If the speed increases from 10 kilometer to 20 kilometers, it takes only half an hour to cover that distance. If that's so, on the other way you can say, if the 10 kilometers time if the time is increasing, if the speed is increasing, we can cover much distance beyond the 10 kilometer, okay? But at the same way, if the speed increases, the time decreases, okay? At the same way, for the same time taken, you can cover more number of distance, or you can cover the distance in a shorter time from the reference. So that here the speed is directly proportional distance and inversely proportional time, okay? So that it is written here, it is by moving the time to the other way, you can say distance equal to speed into time. So divide by time goes there, so it is speed into time. At the same way, if you are asking time, it is distance by speed, okay? As the speed increases, the time taken will decreases and it takes reverse as well, right? So here you can see there are some situations on trains, okay? First one is if a train crossing a pole or a standing man or a tree. Here the pole, standing man and tree have no speed, okay? So the distance covered is the length of the train. See, if a man is standing at this time, okay, if a train is crossing, so the train has to cross completely, means that the train, if the engine is crossing, if just the engine is crossing, we can say the train has crossed. For if a train has 10 compartments, okay, if the 5 compartments or 7 compartments has been crossed them, and we cannot say that the train has. So you cannot say the train has completely crossed the pole or a man or a tree, okay? Means that if a train has to cross completely from the start point of the train to the end point of the compartments or the last compartment, this is where the distance covered as comes into the picture, right? So for example, in that case, the relative speed is, we have to take the speed of the train. So if it comes to the time taken, we can say it as the length of the train by the speed of the train, okay? Length of the train by the speed of the train, okay? If you are taking the next situation, the train crosses a platform, a bridge or a tunnel, you can say that if here the platform, bridge or tunnel have some distance. For example, if the platform, we can say it is around 600 meters, the bridge is around 500 meters, or the tunnel we can say it is it's a 3 kilometer or 4 kilometer tunnel. Here the thing is that, see, if a tunnel is on this at a distance of okay, we can take it as this is the tunnel and the train crossing is like this, we can say the train has to start from the initial point of the tunnel. So the complete crossing happens once the last compartment or the last point of the train has to cross the end point of the tunnel, right? From the you cannot say it is just crossing the start point, we cannot say it has crossed. The thing is that the train has to cross the starting point of the tunnel and it should cross the end point of the tunnel completely. Means that the train should cross the end point of the tunnel completely, not just the engine, not just the 2 or 3 compartments. If the train has 10 compartments, the 10th compartment has to cross completely, then here the distance covered is the length of the train and the length of the platform. So if the relative speed comes into the picture, it is just the speed of the train. Okay, then here the train formula is here you have to take both the length of the train and the length of the bridge plus the speed of the train. Okay, so that's all for today. We'll see the remaining shortcuts in the next class.